Good afternoon, guys. I hope you all are doing okay. Having a good day so far. Hopefully, it's not as hot today. I brought a fan from my house, so let's see if that helps us today. As far as today goes, we're going to be doing some notes as assignment number 9. It's going to be add and subtract radicals. Before we get into the actual notes that I'm going to give you, I want you guys to set up your notebook like this. So there's one page. Let me get this flipped over here. So this is your first page. I want you to split it like this. You're going to kind of draw this line down the center, draw this line down the center, draw this line across. I use 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That gives me enough space to write the objective and the I will, we will. And then it gives me enough space down here to fill in the notes. So I suggest that way. You can do it a little bit different if you'd like, if it's your preference. And then on the second page, see here I wrote the date, Thursday 2/6, and I wrote a little 2 here to indicate that this is my second page of notes. I should have wrote practice on this page as well. You're going to have 4 practice problems. 1, 2, 3, 4, which I'll give you in the next few minutes over the video. You're going to write in adding radicals, subtracting radicals, and I do want you to fill in all these titles on your notebook. So write in assignment number 9, add, subtract radicals. I'll show you what we're going to write here, 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 and here. I'm going to leave it here for just another few seconds so you can kind of see the setup. Pause the video if you need to so you can see how I want you to set up the notebook. So be careful. The first page is like 4 squares. Second page is 1, 2, 3 squares. Okay. I'll also put this up on the front board so y'all can see it. Now, as far as the notes go, I'm noticing a lot of people are struggling to put in their notebook what I'm expecting them to put in. So the expectation here is that as I display these notes and I read them off in the videos, my expectations is that you'll write all of these things down. So I would hope that you'll write assignment number 9 in your notebook. You're going to write the title, adding, subtracting radicals, in your notebook. And then the objective, or what we're supposed to be doing today, is we will define the rules to add and subtract radicals. I expect you, when I'm reading these and displaying them on the screen, to write them in your notebook. So here you should be writing whatever I'm showing you on the screen in the Nearpod videos, or on the videos in Nearpod. Okay, now the reason I want you guys to write these things down is you're not going to remember next week or in 2 weeks or 3 weeks when we take a test what all we covered each day. But if you have your notebook and it's organized and set up and neat, you'll be able to look and say, okay, well, I know Rubio said we were going to be tested on assignments 8, 9, and 10 on this quiz. You can at least go to your assignment 9 and look through your notes and see which parts of the notes are going to help you for the quiz. Or when I say, hey, the 9-week final exam is going to cover assignments 1 through 15. You'll know that you'll have to go back and you'll have the topic of each, the definitions and all the stuff we covered, and you'll be able to use those and more efficiently in your notes when you're actually taking your test. Okay. So again, my expectation is that you'll write everything that's here. What is the radicand? I expect that you'll write it here. What is... The other reason I want you to write it down is because as you write it, it's going to help you keep in mind what it is that we're going to be looking at over the next few minutes and what you need to be learning about. So it'll help your brain kind of absorb the information a little bit better. Okay, so there's a reason for it. It's not just to keep you all busy. It's actually to try to help you guys get your brain ready to absorb the material. And it's also to help you practice for when you go to college in the next year or two, that you'll kind of have a better idea of how to take notes on your own. Okay, so that's how you should be taking down the notes in your notebook. Let's go ahead and get to the actual notes part. Here's what we're covering today. Assignment number 9, adding and subtracting radicals. We will define the rules to add and subtract radicals. Today we are going to figure out what is the radicand and what is the index. So we've got some definitions here. We will define the steps to add and subtract radicals, and you all will use the rules we define to solve problems with radicals. Let's go ahead and define some definitions here. I want you guys to write this down. You're going to have to copy this down in your notebook. So draw the big radical symbol. Okay, this is called the radical symbol. So you should write in your notebook. You should label these radical symbol, just like I have here. The number under the radical symbol, well, that's called the radicand. Okay, so you should write that, radicand. Write that in your notebook. The number underneath the radical symbol is the radicand. And the number out here that's kind of right next to the bracket, it's very small. It's always smaller than the other numbers. Not smaller in value, but in size. And that's your index. So I expect you guys to label these and write them out. On the understanding, check for understanding, I'm going to ask you to label 1, 2, 3, 4 parts. This whole thing, everything all together, is called the radical. Okay, now let's define the rules that we need to know for adding and subtracting. Now we can add or subtract like radicals if they have the same index, the little number up here, and if they have the same radicand, the number underneath. If they're the same, we can add them, subtract them. I'll show you guys an example here. Number 1. Let's take a look. First, what about the radicand, the little number that's here? Well, we don't see a little number here, right? I've told you guys several times, and you should remember this by now. If there's no number next to the bracket, it's implied that it's a 2. It's implied that it's the square root. We just use this symbol so often in mathematics for solving different things that they just stopped writing the 2 because they got tired of writing it. So assume there's a 2 here. And we can say the index is the same here, is the same here, is the same here. So we have one part of the rule satisfied, but the radicands are different. Okay, this is a 50, this is 125, and this is 98. We can't combine them, add or subtract straight out. We have to do some simplification and rewrite by using something we already know. We have the product rule, and then we have the quotient rule. We are going to use these to rewrite these equations and simplify them. And this is why I told you all, if you need to finish your notes from Monday and Tuesday so that we're ready for today to start this new topic. So here's how we're going to get the radicands, the number underneath the radical, to look the same. First, I'm going to write an equal sign. So 2, the radical or square root. Now, instead of 50, I'm going to write the factors of 50. So the multiples, 25 times 2. Minus 3. And instead of 125, I'm also going to write 25 times 1, 2, 3, 4, 5. 25 times 5 gives me 125. Plus square root of, now instead of 98, I'm going to write the factors of 98, 49 times 2. I did have to try this a couple times on my calculator. I guessed with the number 2, 3, 4, and to see which one goes into 98 evenly. 2 times 49 will give me 98. There's a reason why I did this, because now I need to use the product rule. Remember, product rule from assignment number 8 says that we can split this. We can split this into 2 little baby radicals. So 25 and 1 times the square root of 2. And I'm going to carry down my 2 here. This one I'll bring down to 3, and I can rewrite it as the square root of 25 times the square root of 5. And then the last one, there's no coefficient in the front, so I don't bring anything down. But I do have plus the square root of 49 times the square root of 2. The reason I do this is because I can continue to simplify this more and more. Bring down the 2. Now the square root of 25 is 5. There is no square root of 2 that's an even number, so I leave it as square root of 2. Again, the square root of 25 is 5. Once I take the square root of 25, it turns into a 5, and the radical symbol disappears. Times, don't forget, I still have this 5 down here. Plus, this is 7, and I'm going to bring down the square root of 2. Okay, so now I can simplify one more time. Boy, I'm running out of space here. 2 times 5 is 10 times square root of 2. Minus 3 times 5 is 15 times square root of 5. Plus 7 times square root of 2. And look, I've got 10 times square root of 2, square root of 5, and here square root of 2. So these are alike. They have the same index and the same radicand. So I can add them. So I'm going to take 10 plus 7 is 17, square root of 2. Now this, there's no like term, so I'm just going to bring it down. I can't simplify anymore. These have the same index. Okay, it's a number 2, it's a square root, but they don't have the same radicand, so I can't add those anymore. And that's it. That's all we need to do when we're adding and subtracting. So I know it looks like a lot of steps, but it's really just remembering that you need to use the product rule. You'll need to use the quotient rule sometimes, and simplifying, multiplying, knowing your factors. These are all the important tools that you'll need to complete these practice problems. Let's take a look at number 2. This one's a subtraction. So first we need to check. Step 1 is check index. Is it the same? Yes, it's a 3 here. Step 2, check radicand. That's the number underneath. Is it the same? No, because this has an 11, but it's also divided by 8, and this is just 11, and this is another fraction on its own. So because they're not, we have to do some work to get them to look the same. And then once we're done with that, we need to simplify, and then we'll solve again, or solve. Then we'll solve. Okay. So first I'm going to use the quotient rule here. The quotient rule says that I can rewrite this as the cube root of 11 divided by the cube root of 8. Okay, that's a 3. I got it. My 3s are ugly right now. 3. So I'm rewriting this here. Minus the cube root of 3 on the top times 11 divided by 6. Okay. Now here I need to simplify a little bit. Okay. If I take the cube root right here, the cube root of 3 is 2. Because 2 times 2 times 2 equals 8. Okay, 2 times 2 times itself 3 times gives me 8. That's how these radicals kind of work. So I'm going to have the cube root of 11 on the top, the number 2 on the bottom, minus the cube root of 11 divided by 6. Okay. Now I want to subtract these, but I don't have the same denominator. So now it's like we're combining radicals on top, but fractions on the bottom. We've got to remember the rule that we can't combine, add or subtract fractions without having the same denominator. So I have to convert this 2 into a 6. I have to change this 2 into a 6 so that I can, oh no, my thing's freezing. Let's give it a sec. Okay. Change this 2 into a 6. The way I can change that 2 into a 6 is by multiplying it by 3. If I multiply the denominator by 3, I multiply the numerator by 3. Okay, so remember, this is still 3 square root of 11 divided by 2. This one, I didn't do anything to the second term, so I leave it the same. 3 times the cube root of 3 equals 3, the cube root of 11. So this is a multiplication there. Divided by 3 times 2 is 6. Minus, and there's no coefficient here, but we can know or assume that there's a little 1 invisible there. Cube root of 11 divided by 6. And now I can say 3 minus 1 is 2. I've got the cube root of 11 on the numerator and then 6 on the bottom. Remember, this cube root, this little 3 right here, is telling us to operate on the 11 and the radical, not a multiplication between 3 and this 2. Okay, it does not mean multiply there. This little 3 belongs with this little symbol, which belongs with the 11. So now 2 over 6 can be reduced to, let me write it larger here, 1 over 3 times the cube root, oh no, let me write it over here. One third times the cube root of 11. And really, we don't need to write the 1, so we can just write the cube root of 11 divided by 3. And that's our final answer. Okay, I expect that it's going to take you some time to solve these problems because of the number of steps. So what I want you guys to do is, on this part of your page, on your notebook, you're going to write number 1, copy this equation down and solve it. Number 2, copy this down and solve it. Number 3, solve. Number 4, copy and solve. Okay, so you should have these 4 problems. And then once you're done with all that, I want you to understand or try to summarize what you learned by identifying the 4 parts of the radical in the diagram below. I expect you guys to go ahead and draw this symbol, write in the number 27, write in the number 3, and then draw these and show me what, or label these and tell me what each one of these parts is called. Okay, that's going to be your check for understanding once you finish the practice problem. My expectation for the notes is that you will do all of these parts. That's how you'll score 100 on your notes. If you're missing any pieces, that's we'll start taking points off for your grade for your notes. Okay, I'll be in class obviously, and Coach Taylor should be around too. So let us know if you all need help.